In this video, I want to push our discussion of asynchronous JavaScript forward by talking about promises in JavaScript. We're going to be learning about the Promise API and how that is going to allow us a different and, in my opinion, better way to structure our asynchronous code. Currently, if we were to go over to app.js, we can see that we're structuring things using the callback approach, which did indeed make it very easy to separate the usage of the data from how the data is actually fetched. In this case, we pass a function to getPuzzle, and I hope that in the future this function gets called with the correct arguments in the correct order. This is via callbacks. What we're going to do is explore how we can structure this using promises. As with all new features, it's usually best to explore them in isolation, then bring them into the application we're actually working on. That's going to make sure we actually understand how things are working, and then we'll integrate them into the program. To do this, we're just going to make one new file over in the functions folder, and I'm going to call this promises.js. And in here, we're going to play around with how exactly we create and work with promises. We're also going to directly compare and contrast the standard callback pattern with the promise pattern. Now, in this file, we're going to simulate a delay. So we're not actually going to make an HTTP request. We can simulate a delay in JavaScript by using setTimeout. setTimeout allows us to run some code after a certain amount of time has passed. It takes two arguments. The first one is the code to run after a certain amount of time has passed, and the other argument is how much time you want to wait. And this time is represented in milliseconds. So for our purposes, let's just wait 2 seconds, which would be 2000 milliseconds. Now inside of here, we can do some work. Console.log. The time is up. The result of this program is just going to be us seeing our message after 2 seconds have passed. Before we continue on, we can actually just run this file. Node promises.js. When we run it, we see we get a blank screen for 2 seconds, then we get our message, then the program completes, bringing us back to the command prompt. So as we explore promises outside of the scope of our Hangman application, we'll be using setTimeout to simulate this delay. Now, it's going to be important to compare and contrast the difference between standard callbacks and promises, so I'm going to start by creating a standard callback example. Get data callback. It's just going to be a function that takes a callback, and then after 2 seconds, we'll call the callback with some dummy data. Right here, I can cut out my setTimeout call. I can paste it in, and instead of using console.log, I'll just call the callback passing in the arguments. Let's say the first one is still the error. I'll set that equal to undefined. And let's say that the second one is the data, and I'll just leave that as what we do pass in. This is the data, obviously using dummy data. Now we know how we would use this. We would call it getDataCallback. And I would pass in my callback function. This is the function where we get any potential error or the potential success data. We could then finish off our arrow function, and right here we would be able to access that information. If there is an error, we can do one thing. If there is not an error inside of else, we can do something else. For else, let's just print the data to the screen. Now, if we run this program, once again, we know exactly what's going to happen. I breezed through that example because we've seen this before. I wait 2 seconds and I see my data printing. This is exactly what we did by creating getPuzzle and using getPuzzle in app.js. Now I want to explore how we can get something very similar done with the Promise API. Then we'll be able to easily compare and contrast the two techniques. So down below, promise. Up above, I'll leave a comment for this one. Callback. So the promise technique starts by creating a new promise, using new with the promise constructor function. Let's start by creating a new variable to store our promise. We can call it something generic like my promise. Then we're going to create our first promise using the new operator with the promise constructor function. Now, the promise constructor function is not something that we create. It's built right into the language, and it does indeed expect a single argument. This is a function. So right here, we're going to pass in a function, and it's more than okay to use an arrow function in this situation, since we're not going to be using this or arguments. Now, what is this function? Well, this function actually gets called right away. In here, This is where we can perform our long-running process. So that could be us making an HTTP request to save some data to a database, or in this particular example, it could be us using setTimeout to simulate a delay. So right inside of here, we're going to use setTimeout to simulate a delay, just like we did up above. The first argument is our function, and the second argument is how long we want to wait. And just like we did up above, we're going to go ahead and wait 2,000 milliseconds, which would be 2 seconds. Now at this point, hopefully we can see the similarities between this and what we have up above. The function that we have right here looks pretty close to the function we have up here. This is where we put our long-running process. Now up above, once we were ready to actually call the callback, we had access to an argument called callback. We called it, and we passed in the 2 arguments, only defining 1. The question is, how do we do something similar down below? Well, when the promise constructor function calls this function right here, it calls it with 2 arguments we can use. The first argument is resolve, and the second argument is reject. We can call resolve to say that things went well, that we were able to successfully perform this long-running operation. We call reject if things went poorly, if something failed along the way, whether we used invalid arguments or the data we tried to access did not exist. So inside of this function, we're going to call either resolve or reject. Let's go ahead and say that things went well, just like we did up above. So up above, we had to call the callback. We had to fake the first argument, setting it equal to undefined, saying there was no error, and then we passed in our data for the second. With promises, we actually have 2 separate functions. So if nothing went wrong, I just call resolve, and I pass to it my data. So just like I did up above, this is the data. Excellent. Now at this point, we have set up a promise. Let's go ahead and actually use it. So I want to do something with the data, much like we do something with the data down below. To do this, we're going to move down below our promise right here. What we're going to do is call a method on our promise instance. Remember, we're creating a new instance of promise by using new with the promise constructor. So this, my promise, is the promise instance. The method that we're going to be accessing on it is called then. That would be myPromise.then. This lets us define what we want to do when we actually have the information. In this case, when we have our fake data. In the case of a real application, when we have the HTTP request information. For now, we are going to call then, and we pass to then a function. This function right here gets called when the promise resolves, meaning that things went well, and we get access to the data via the first argument. So let's go ahead and actually use it. Console.log, I'm going to log out data. Now to make the output from the 2 a bit different, I'm going to say this is the promise data. Excellent. At this point, we can actually save promises.js and for the first time, run our little promise example. What are we going to do? Over here, we are going to rerun the script. We're going to sit still for 2 seconds and wait. And then after 2 seconds, we can see that both of our messages are printing. We are still getting this is the data from our callback solution. Down below, we're getting this is the promise data from the promise solution right here. Now, before we really analyze the syntax and start comparing and contrasting, let's just look at how we could potentially have an error be the result instead of the success case. Up above, for the callback solution, we know how we would do that. We would provide the first argument instead of the second. So right here, we can pass a value in for the first argument. This is my callback error. And for the second argument, we can either leave it undefined or literally pass in undefined. Either way gets the job done. Now we know that means that the error value here will be set up. We can then check if it is set up, and if it is, we can do something with it, like console.log, just printing the error to the console. Now this is how we would do it for the callback solution, and if we were to run the program, we would indeed see this is my callback error showing up. Over here, we still need to wait our 2 seconds for the setTimeout call to happen. Right here though, we do see this is my callback error. How do we do the same thing down below? Well, instead of calling resolve, we just call reject. So right here, I can comment out my call to resolve, and on the next line, I'm going to call reject instead. We just pass in a single argument, the error that we want to send up. In this case, whatever we would normally pass in as the first argument to callback gets passed in as the first argument to reject, the first and only argument. Right here, let's go ahead and provide an error. This is my promise error. Now at this point, if we were to save the program and rerun it, we would get all sorts of errors and warnings. We can actually prove this by saving the program and rerunning it. I'm going to clear the terminal output just to make it really easy to see what's new and what's old. And then I'm going to rerun the script. We're going to wait our 2 seconds, and what we get is a whole bunch of output showing up, a whole bunch of warnings. And what we really notice is one important thing. We are seeing the error message from our callback example. Nowhere am I seeing the error message for the promise example. That is because we do not have a handler set up for it. This function is only ever going to fire when the promise resolves. It only ever takes a single argument, the data, for when things go well. If we want to do something for when things go poorly, we have to set up a second argument for then right here. This second argument is only ever going to get called when things go poorly, and it gets called with the error. So right here, what can we do? We can print it, console.log error. So all of the warnings in the console are just letting you know that you have a promise that rejected, but at no point are you doing anything with that error information, which is most likely not what you want. In this case, we do want to do something with the error, and we've kept it as simple as just printing it. Whoops, I got a small typo up here for reject. This should be promise, spelled correctly. Awesome. Now let's go ahead and run the program and see what we get. In the past, we got an error letting us know that we were not handling the problem with our promise. This time around, we do have a handler set up, and if we run the program, we get the expected results. We have this is my callback error for the callback pattern. We have this is my promise error for the promise pattern. Now that we've seen a basic example, I want to dive deep into how promises work, comparing and contrasting the two. The first thing we're going to notice with the Promise API is that it's much easier to reason about. Now, it might not be easier to reason about at first because it's a new tool, but let's explore what I mean. Up above, we have a single argument callback. This callback argument doesn't necessarily denote whether things are going well or poorly when we call it. The name isn't specific because we just have one. It is the order of the arguments which allows us to determine whether things went well or whether things went poorly. Down below, we have clearer semantics. We have resolve and reject. We know that if we see resolve, things went well. We know that if we see reject, things went poorly. I don't have to look at which argument was provided and which argument wasn't in order to figure out if things are going well or if things are going bad. Now, the other nice thing is that with callbacks, it's totally possible to call your callback twice. I can go ahead and add this right here, maybe by mistake, and that is going to result in 2 errors showing to the screen. This is not something we're going to want to do for our applications because it could result in extremely unexpected behavior. We might try to start 2 games, crashing the program, or causing something weird to occur. With promises, it is impossible to run more than just one of these functions, and it's only ever going to run once. You cannot resolve twice, you cannot reject twice, you cannot resolve and then reject, or reject and then resolve. You can call one time, everything else is going to be ignored. Let's go ahead and prove this. What we're going to do is duplicate our reject line right here, and we're going to see how the 2 examples differ. I'm going to save promises. Over in the terminal, I'll use clear to clear the output. We can rerun the file and see what we get. Over here, what do we get? I get this is my callback error twice, something that we didn't want but came up by mistake. If I make the same mistake with promises, we can see this is my promise error only shows up once. So with promises, we can reject or resolve the promise a single time with a single value. There's only one argument for each of these functions, resolve and reject. If you want to pass back multiple pieces of information, just put all of that information on an object and resolve or reject the object instead. Another nice feature of promises is that we don't have to know what we're going to do with the code before we start the process of fetching the information. So up above, I have to define my callback that uses the data before I can fetch the data by nature, because I have to call getDataCallback with it. Down below, once the promise starts its process, we do not need to attach then to start waiting. If I was to add this code in, it would still reject just the same. We've just chosen to do nothing with it. We could do something right away like what we had before, and we could access it multiple times. For example, I can take the same code and paste it down below. Now we are waiting on the single promise to either resolve or reject, and when it does, we run the appropriate function. By using then twice, I am not requesting the data twice. I'm just doing two different things with the same information. We can see that this works by saving promises.js. Over here, I'm going to rerun the script. We wait our 2 seconds, and what do we get? I get 2 calls to this is my promise error showing up. And that is because we have 2 calls to then right here, but we did not have to wait 4 seconds. We just had to wait 2 seconds. We waited for the promise to resolve or reject, then both then methods responded to it. That's where I'd like to stop for this one. Now, we are by no means done discussing promises, how they work, and their advantages. We're really just getting started. In the next video, we're going to start integrating what we've learned here into the requests.js file. We're going to convert both getPuzzle and getCountry to use promises. Then we'll continue on exploring other awesome promise features that we just cannot accomplish using the callback pattern. That's it for now. I'll see you in the next one.